Hey there, welcome back. Today we're going to be working on a 4L60E, tearing it down, inspecting it. This is a core, I don't know anything about it. It's a model year 2000 good wrench reman transmission and is set up to work in behind a small block Chevy Gen 1 5.7 liter. We're going to be converting it over to an LS, so we're going to be swapping the bell housing, the input shaft, and the stator shaft so that it'll work with that engine family. It's going into a 2002 Silverado 4x4. So let's go to a little bit closer to the bench and we'll begin. Okay, first things first, I want to take the bell housing off. So what I've been doing is getting it up against the wall, just like this. You can check end plate too, which this has very, very little end plate. It feels like maybe about 10 to possibly up to 15 thousandths, but you really can't start feeling end plate physically when the trans is on the bench horizontal like this, at least the transmission that's awaiting teardown, until you get to about anywhere from 13 to 15 thousandths of an inch. So all the bolts here are Torx plus 50. It's not recommended that we'll actually just never try to take it out with a regular Torx 50 socket. So get it up against the wall, or some guys will literally bolt the transmission to the bench. Use your body weight to kind of keep the socket firmly engaged with the fastener, and then just withdraw. Make sure you're on loose, and then go and pull out each one. Alright, these things should only be installed with about 35 foot-pounds of torque. So sometimes though they get corrosion bonded to the threads in the case, and they won't want to come out, at least not right away. Alright, 2 more to go. Alright, last bolt. Oh, no, we got one more bolt, sorry. A little over eager there. Well, one more bolt hiding down here. And the last bolt dooms us. Alright, so I'm literally going to have to cut this bolt off with a Dremel and take it out that way, or drill through it to cut the bolt in half. So I'll bring you back once the bell's off. Alright, that's my way of getting it off. Works quickly. This particular location is very, very tough to get at from inside the bell. So I had to, just basically destroy it to get that bolt off of it. All right, so let's continue. Again, not very elegant at all, very messy. It is what it is, unfortunately. So 13mm on your pump to case bolts. Get these out of the way. I have like 5 or 6 of those bells in particular, so I'm not too worried about it. Is what it is. I mean, it sucks to have to destroy an otherwise perfectly good part, but sometimes you gotta do what you gotta do. Alright, servo. So no different than any other transmission 704 4L60E that you've ever seen me do, or that you might have done. Just take your hammer screwdriver, go ahead and tap it, and then if you want, you can kind of loosen it up a little bit, and then come in here with a screwdriver, start kind of prying out on the cover, Main thing is you want to get that O-ring exposed so that you can remove it. And that's the O-ring right here. And this one might be stubborn. I have a feeling this core is going to be, at the very least, very frustrating to deal with, at least on teardown. I'm hoping that it's not all destroyed inside. I'm hoping that at least the back half of the transmission is good. I don't care about the pump, and the 2 drums are getting replaced anyway, but I don't want to have to replace gear sets wholesale, or find the case itself is somehow destroyed, particularly either in the low reverse piston area or the area around the center support. This thing's got wedged in here, so there we go. Alright, so servo and cover, this goes inboard. You can run billet servos here for your 4th gear. If you're doing a lot of towing and hauling, it's what I'd recommend, or for anything like real high performance. It's got a little bit of a chip there. That might have been me, I don't know. But we're not going to reuse this piston. So anytime you see something like this, just get another one. Chuck that in the bin. Alright, let's see what we got for a 2nd gear servo assembly. So it's going to be your standard 553 servo, and I'm referring to the last 3 digits in the casting number there. If you can see it. I always replace these with another 2nd gear servo, most commonly the Corvette servo. If you're going to run the Corvette servo in a stock application, my advice would be to not drill the 1-2 feet at all, just keep it the way it is. The Corvette servo by itself will crispen up the shift, it'll make it a little bit firmer, and it actually should feel just right. These pins are selective. You have grooves in the head of the pin to help you determine what version you're working with. So this is going to be the most common. It's a 2-groove version. It's the 3rd longest. There's, I think, 4 of them. So you have a no groove version, that's going to be your longest, then 1 groove, 2 groove, and 3 groove, which is going to be the shortest. So alright, so if you're running a Transgo shift kit, there'll be 2 other springs, actually 3 technically, 3 other springs that they're going to give you to put inside this this housing here. And get this underneath, snap ring, and take it out. So here we have just the main spring. GM also makes a secondary interior spring. And what those springs do is they're designed to soften that otherwise harsh 3-2 downshift that these transmissions are known for. And so you can add that spring. I'm not sure what the part number is. I'll flash it across the screen so you know. But bottom line is that one of the most common complaints of these units is going to be harsh 1-2 upshift and harsh 3-2 downshift. You know, it's their kind of neck and neck as far as drivability pain points. Alright, looks like we'll need a set of pan bolts. 13 millimeter. Somebody put a drain plug of sorts on here. That bolt is way too tight. Look at that, Rust City. Whew! It's like this thing was submerged in the bottom of the ocean, and oh man, look at this. And we got a small field's worth of dirt in here. Jesus. Or 13 millimeter. I have tons of valve body, so that's not a concern. I mean, all this is going to go into the scrapyard. It actually makes the cleanup a lot easier. I'm just going to toss all this shit into the garbage instead of, you know, cleaning it off. I mean, there's no point. You would never ever reuse or run a valve body or accumulator or anything that looks like this. All right, so 10 millimeter on most of the bolts here, except for these three. These are 8 millimeter. They have to go back in the same location. Otherwise, if you put, say, this bolt here in this location or this location, you might lock up the sun shell. These three bolts are a little bit longer than the rest of them. Then you have 8 millimeter bolts here, and then there's 3 8 millimeter bolts on the reverse hold down plate. Maybe the reverse hold down plate is salvageable. I don't know. So 10 millimeter on the torque converter clutch solenoid bolts, and then, like I said, 10 millimeter bolts pretty much everywhere else except for the other bolts I specified. What a mess. So we're going to be putting a deep pan on here. This is a shallow pan. So we already know that somebody, whoever did this or messed with it, put the wrong pan on. All the two-piece case designs from 98 on up, or actually 97 on up, had a deep pan. One more here and one more there. Okay, if any of these bolts strip out, you can basically take a cut-off tool similar to what you just saw, cut a slit right in the middle of the bolt, or like a flathead screwdriver, and then a lot of times just the heat alone of you making that cut will be enough to loosen up the bolt, free it from the bond it has with the threads in the case, and allow you to take it out. But if not, then just take your impact driver and pound on it while twisting leftward or counterclockwise, and that will get the bolt right out for you. So nothing to fear if that happens. Alright, these bolts are going to have to go through like a deep cleaning, and then they'll have to be inspected to see if they're any good or not. So I don't have my air on, so I'll punch that out later once I turn the air back on. Get this off of here. I mean, I guess you could try to salvage this valve body. You disassemble it, clean it, and then polish all the bores with bench buddies. I mean, look at that. Is it worth the effort? Probably not. And there goes all the check balls. It looks like the manual valve is even caught up in here. So, yeah, pretty nasty. So if you're working as, on a vehicle from 96 to 06, pretty much any valve body will actually work. From 1996 through 2006, you just need to match the spacer plate to case and to valve body gasket set with whatever valve body and spacer plate you're using. So if you're in a jam or the spacer plate's no good, just purchase the Transgo 4696 plate, and that will allow you to run, pretty much any valve body in that vintage that I specified. 93, 94, those valve bodies are interchangeable with those 2 years. 95, it's its own year, standalone year, so to speak. And then 96, 06, and then 07 and 08 is another vintage. Those valve bodies are interchangeable. In fact, you can really, technically speaking, run any 96 to 08 valve body on any 96 to 08 transmission. Okay, like I said, the only differences are really subtle changes with the torque converter clutch regulator valve and valve body. So valve lineups changed a little bit. The design of the valves changed a tad. I have a chart somewhere. If I can find it, I'll flash it across the screen. That shows all the different iterations of that particular valve frame over the years from 1995 and beyond. Yeah, so this plate's no good. I mean, it could probably be cleaned up, but again, I'm not going to bother. Unfortunately, when it comes to cores, sometimes you get lucky, sometimes you don't. Sometimes you're going to be into it for maybe a little bit more than you anticipated, but it's not a huge deal. I have tons and tons of these parts, and they are pretty much ubiquitous anywhere you go. I mean, you know, you're gonna be able to find them, and for not too much money. So, all right, I gotta punch this out or pry it out. Nasty. Alright, we got a check ball for the fourth accumulator. So if you want to block the fourth accumulator, you can. There's an orifice or a feed right down here. I don't know if you can see it from where you're at, your vantage point. Let me try to zoom in real quick. Like I said, I don't know much of the history of this thing other than what I'm seeing, which indicates it was either in a mud pit or underwater at some point, or, you know, some animals nesting in here. But you want to block this off, and I use a set screw. I don't use a check ball. 1/4 inch set screw, approximately 3/8 of an inch long, and you know, with an Allen head fastener type, it'll thread right in there. You don't need to drill or tap or nothing, just thread it in and it's done. And you can reverse this if you wanted to quite easily. With a check ball you can't. Now this little orifice right here, all right, a lot of people seem to think that's a lube circuit. It's not. It's just an air bleed, so be aware. All right, 13 millimeter here on your parking pole guide plate. There we go. To get at that other bolt right here, you're going to have it in the park. Alright, that looks like it's salvageable. Alright, then you have 15 millimeters here on your rooster comb nut to selector shaft, or selector shaft to rooster comb, however you want to say it. So just beat that forward, and then take your screwdriver and the band style little spacer, and then, like I said, these always give you grief. So I have to get a pry bar to get that out of there. This looks okay. I see a little bit of surface rust, but nothing alarming. I don't mention this with 4L60Es, but I do with the 6Ls, but you want to check the rivet. I've never seen one of these actually bad, you know, where the parking pole actuator is actually separated from the rest of the rod assembly, but you never know. I'm sure somebody has at some point, so it's something that I should be checking for a lot more commonly than I do. With the 6Ls, you just replace that parking rod with the updated one, that's all. Alright, this thing's got a weird smell to it as well. It actually smells a little like water. You know, like it's been underwater. Alright. I really should get a broom on here. In fact, I think that's what I'm going to do. Make sure I get all the check balls. I want them swept up. If nothing else, it's been an interesting teardown so far. I haven't seen a core quite like this come in a while. Or I needed a broom instead of a squeegee or a trowel to clean the bench off. All right. So let's go ahead and see if I can get this out. Probably not, but let's just see. Sometimes I get lucky, these will come out. Manipulate the band from under here. But most of the time they're jammed up, so not entirely unexpected. Alright, so when you want to take this pump out, it's easiest just to come in, and then you want to have the curve, the pry bar facing rearward, so that you can keep keep the reverse input drum from sliding out with the pump. Because if the band is still engaged, then it's going to be a problem. The band's going to get caught up. So the band's still loose. And you dislodge it, and then now everything should come out. The other thing I was worried about was the 3/4 clutch pack being welded to the 3/4 clutch hub, in other words, the ring gear. Okay, band looks worn, rusty, but otherwise unremarkable. As you can see, the drum is no good. The reverse input drum, that is. And then we have snap ring here. Let me turn this. Ooh, this doesn't feel good. This should turn nice and easy, and it does not. Does not feel good. Maybe the little roller clutch is destroyed or something. Where would I put the opening at? Right there at the 7 o'clock. Oops. All right, now I'm going to try to beat that out. Or at least tap it rearward. Let me see this come out first. Oh, good. It'll come out. All right, check everything in here. Interesting, that's painted. Check it again, double check it. At least for me, I will put an orange mark on a pinion if I know it's bad. Check these splines, check journal surface, check for bluing. I don't see anything like that, so that's good. Alright, got a little bit of rust here, but this should come off, no biggie. So this is a bronze slush washer. This was replaced by a Torrington bearing for all units 2003 and above, or later. So I'll put a bearing kit in here because, well, I don't trust any of these bearings. So let's see. Yeah, that's just surface rust. That should be fine. Come on. Alright, more surface rust. Check these lugs, check for chattering here, especially on the sidewalls of the lugs. If it's a real bad, the 3/4 clutch will start to get hung up on there, the frictions will, and you'll have either a no apply situation or, you know, slipping, delayed engagements into third gear, whatever. So if you see that, just get rid of this and replace it with something that isn't, you know, so worn out. Check the teeth in here. Make sure that the crests are in good shape. Make sure there's no cracking or anything like that. I mean, all basic stuff, to be honest. All right, now here's where you want to really pay attention, because I'll see a lot of 4L60Es, 704s come in with excessive wear here on the splines that engage that 3/4 hub. This is a little bit worn, but it's not the end of the world. See, the surface rust just comes off. If you see pitting, like you see surface rust, you wipe it off, but then you see pitting, it's my recommendation you just replace the part. This one's kind of borderline, to be honest. Check the splines here, make sure they're okay. Obviously replace your bushing. Okay, sun shell. We're going to be installing a Sonic Smart Shell into this thing, so this washer will be deleted and replaced by a Torrington bearing from the sun shell kit from Sonic's. Let me see if this shell is original or not. So the aftermarket heat-treated shells have heat-treated splines, and it's very noticeable. I mean, you can easily tell and distinguish a purely factory shell or factory-grade shell from the aftermarket heat-treat versions. This might be a heat-treated sun shell, but it's got rust on it, so. And this rust is not just surface. I mean, it's hard rust. It's probably pitted underneath. so that'll go into the scrapyard as well. And then we have our center support with our sun gear in there, the rear sun gear, and yeah, I don't know. Let me get pliers. Yeah, it doesn't want to come out. Not good. Let's look at the output shaft. Dirty. We got some surface rust. Check these splines and these splines as well. This is dirt. I mean, it's coming right off. So this is actually okay, at least at first glance. And I say at first glance, I'm doing a lot of qualifying here because I don't ever actually inspect any parts for real until they're all cleaned off. So far, so good with some of these parts, but you don't really know until you have them clean and they're ready to inspect at that point. Now normally I would turn the shop air on and force the whatchamacallit out, but I don't know if that's gonna work or not. So what I'm talking about is you have your you're gonna have your low reverse feed right here. What you do is you take your snap ring pliers, you know, just like these, and you position them between the anti-clunk spring in the case and one of the case lugs. You expand the pliers so that the anti-clunk spring is no longer you know, making contact with the center support in that location, and then you force air into the low reverse feed. That will push the piston forward and push everything else forward past the snap ring groove so that you can just, you know, quite easily pull the center support out. So let me actually go ahead and try that and see if it'll work. And then if not, I'm going to just turn the whole case, put the output shaft back in, turn the whole case right side up and force it down on the bench and see if that dislodges everything. Okay, pull this a little bit closer, have the air on. So I'm using about 120 psi air to do this. So we're going to take our pliers, get up in here inside the case, spread the pliers so that the anti-clunk spring is no longer engaged on that one side of the center support, and then we're going to, you know, put air here to force everything forward. All right, let's see what we got. All right, let's look at the center support. So I want to see if there's any rust here on the apply surface, and I don't see any. I mean, I see a lot of surface rust here, but let's see if we can wipe that off. Seems to be okay. I mean, I think the rest of this will come off in the cleaning cycle. You can also use rust remover. Again, if it's surface rust and there's no pitting, it should be fine. So here's your roller clutch rotation, freewheels clockwise, locks counterclockwise, and that's the inner race. So that appears to be okay. So our low reverse clutch pack. You want to be mindful of the presence of what we call selectives. So this is a good example. If you noticed, this is the cushion plate, and then we have a steel here that's markedly thicker, noticeably thicker than all of the others. So this is a selective steel, and it has a number 1. It's going to be on the notch. So it's a good example of a unit that's equipped with a selective. So I have a whole video that does a kind of a deep dive into the low reverse clutch pack, and included in that video is the procedure for how to measure your clutch clearance. So it involves using the center support, your clutch pack, and then you got to take measurement vertically, and I think your measurement needs to be somewhere 1.2 to 1.240 inches from the bottom of the center support here, okay, with all the clutch stacked up, to the top. and that's with the cushion plate installed. Alright, so this is not going to come out. Looks like we might be into it for a planet set. And looks like we don't have a snap ring here. And then we, of course, have a failure at the rear ring gear. So failure with the rear ring gear is actually somewhat common in these units. In fact, GM went to the 5-pinion planets not to beef up the transmission, although they do give the 4L65 and 4L70Es a higher torque rating. But I think that has more to do with the induction hardened components in those transmissions, the splines for the stator and the input shaft, than it does for the gear sets. But this happens because there's excessive load on the inner portion of the ring gear here. So when that occurs, I mean, you'll eventually have catastrophic failure on the likes of what you see here. Alright, so this is jammed up in there. I don't think it's welded, but I could be wrong. It'll come apart. Alright, both the planet and the ring gear are scrap. Sun gear probably too. Really need a bigger pry bar over here. Alright, got it separated. So, again, somewhat common. The 5-pinion planets spread the load on each of the, all around the ring gear a little bit more evenly. It's a little bit more diffuse, so less stress on any one particular location where that planetary happens to be riding upon. So that's the primary reason they did that. Is it me, or does this sun gear actually look okay? It might be okay. Alright, these bearings are obviously no good. I mean, the primary reason you have gear train failures like this, actually two reasons. One, and they both have to do with the person operating the vehicle. One, you have somebody just beating on it like mercilessly. Alright, you beat on a vehicle mercilessly, parts are going to start breaking. The other reason is either insufficient fluid levels in combination with beating on it and restrictions in the system. So I tell everybody, all my customers, they need to flush their lines, their coolers, the entire system out prior to reinstalling the transmission, because if they don't do that, they do run the risk of having a failure quite like this. I mean, you see all the teeth here ground down to the nubs. And of course, see the housing breaking off here. I mean, anti-plunk spring's seen better days. I'm not going to reuse it. And then we have our snap ring. So snap ring popped out. So going to be into it for a rear gear set. Sucks. And then we need to get that low reverse piston out of there, the return spring assembly. So I'm going to fetch the tool and then bring you back and we'll do that. Alright, tools in position, and the ends of the snap ring are roughly at 3 o'clock, so let's see if I can get up in there real quick and yank it out. One thing I notice here, and unfortunately you're not going to be able to see this, but the snap ring is not engaged on all 4 of the locking bosses on the return spring assembly. So I don't know if that contributed to what we saw here directly. I mean, probably not, but it's just recommended that when you go back with it, you have all 4 engaged. I'm going to crank down on that a little bit too tight because snap ring ends are sliding underneath. the snap ring. Alright, the turn spring assembly should just pop out, but if it doesn't, then, you know, a couple of taps on it with a hammer handle and it'll come right out for you. Alright, last thing to do is just pop it out. Alright, so this case is empty. The case itself is probably going to have to go to the machinist. And the reason for that is that piece of bolt for the bell housing to case is still stuck in there. I'm going to try to get it out myself, but if I cannot, I'll take it to the machinist. So what I did here is I cut a little slit into it to the extent I could. I have a fairly wide impact driver bit, you know, flathead bit. So I'm going to use that in a manual impact driver with a very heavy hammer to see if I can force it out. You know, I'll put WD-40, I'll heat this area up as well, and maybe that'll get it out. If not, then I'll have the machinist do it. Alright, always check your low reverse piston casting. If you see 725, last 3 digits, discard that piston, do not use it. There's a bulletin or a blurb in the ATSG manuals. ATRA I think has one as well, that those pistons are unusually prone to failure, to cracking. You know, they're basically defective casting. If you have either slipping or, you know, no reverse clutch burnt up, it's this inner machine seal that is usually the culprit. This one seems to be soft and supple, but many of them are hardened, and they're hardened due to overheating because there's some heat that builds up in that area. And again, that could be due to a variety of different reasons, including user, you know, owner driven, if you will. Alright, that over there, that here. Alright, let's take a look at the drums real quick. Neither of these drums are going to be reused, and that was the plan from the very beginning. So, you know, when I price out a core, I always price in the possibility of having to replace these drums. If the drums are good, then I'll you know, I'll deduct them from the invoice, but it's very rare. So, you know, I tell customers, you know, just the cost to have me go through a core for you is going to be a little higher because we have to account for drums. All right. So the low reverse clutch in this particular unit has definitely seen some stress, some heat. I mean, no signs of excessive slipping. I mean, the clutch ain't burned up or anything, but I mean, you could see, thinking somebody went through this unit at some point in the past. They reused the steels, and they probably should have put a steel module in here. Alright, these steels need to go into the garbage. Scrap them. I'll take that stuff out at the press later. I'm not going to bother testing this drum. Like I said, it's not something I'd ever reuse, given what I've already observed in this transmission. So as for your selective spacer, this is a number 69. They're numbered from, I believe, either 66 or 67 up to 73 or 74. The smaller the number, the thinner the spacer. You want to shoot for between 10 and 30 thousandths of end play for these transmissions. And that's going to be measured at the front. However, anything you do inside the case, as far as, you know, shims underneath bearings, or, you know, inadvertently installing a bearing upside down or backwards, will affect that end play. Common mistake that first timers might make is installing the rear thrust bearing for the ring gear. Oops. The rear thrust bearing for the ring gear that goes right here, installing that backwards. That will shrink end play by about anywhere from 25 to 30 thousandths, all other things held equal. And so I think load release springs have been installed. Different implement here. Hopefully the contents inside this drum are in decent shape. There we got load release springs. Three-four pack actually doesn't look half bad. I mean, it's got wear to it, but it's not smoked, it's not destroyed. And there's still meat on these frictions. The steels show the normal signs of heating. This thing takes the brunt of the heat generated in the transmission insofar as all of the applied elements are concerned in the normal course operation. So in other words, all things held equal, assuming a well-maintained system, the 3-4 pack's going to see the most heat. But it doesn't mean that you can't set it up for success and then it's not survivable. It just means that it is the most vulnerable in that regard. That's all. I had to dig those out of the trash because I forgot the customer actually wants to see the components, so I'll take pictures and I can send them to them. So always check these lugs here. You want to see kind of what you see here, which is no chattering or grooves or ridges cut into the lugs by the reverse input clutch. And so if you have that, here's where your reverse clutch goes, you'll have hang-ups, okay? In a real severe case, a no-apply situation. So avoid that if you can, by replacing this drum if you see a lot of excessive wear on these lugs here. Alright, normally you would put fluid in here to test for leaks where the shaft's pressed into the drum. If I keep this drum, if the drum itself appears to be in good shape, I'm probably just going to press the shaft down, put something else in it anyway, so I'm not going to bother. Alright, I had to change battery out, so that's why the angle is just a little bit different than what you just saw. So forward clutch clearance should be somewhere between 30 and 63 thousandths, I believe. And this particular clutch looks like it's got a little bit more than that. I'll grab up on it. Alright, so change camera angle again. So forward and coast clutch, looks like we got some rust on the frictions and steels. Well, I guess the steels or frictions don't have rust on them, but they're worn out. I mean, you can see signs of heat sustained right in here in the inner diameter. So some signs of slipping on the steels. And then for our sprag, this is rotation. So when you're holding the inner element, so if you want to hold either the gear or the coast clutch hub, the outer race rotates clockwise and locks counterclockwise. Here, let's look at the plate. So you see some slip marks there on the applied plate, or backing plate I should say. Not a huge deal. I mean, that could be prepped out. And then here's our cushion or wavy plate for the forward clutch. And then here's the backing plate backing plate appears to be good. Frictions and steels. And the frictions in here look decent. If you have a lot of slip marks, a lot of signs of slipping and or other impairment, then you really need to scrutinize all your drum components, as well as possibly valve body, separator plate, etc., because the forward clutch is always on in these transmissions. It's not really a working clutch per se. As long as you're in a forward range position, so drive 4, 3, 2, and 1, the forward clutch will be applied. It only comes off in reverse, neutral, and park. So if you have a forward clutch come in all damaged, you really need to find out why that happened so that it doesn't go back in and have, repeat of history. Alright, see if this hub has just surface rust or if it's deeper than that. Looks okay. And we got some rust here on the lugs. Check these lugs again. You're looking for chattering. Anytime you have a hub that is splined with clutches, the first thing you really want to look for is the evidence of chattering or grooving or ridges cut into it, because if so, then you just want to dump it. It looks like we got a chip here on the outer race, that lug right there. It's going to be your forward clutch hub. Take some 350 grit sandpaper and go all the way around in here to reintroduce cross hatching. I'm gonna have to put another one in here, but suffice to say, other than that little chip, that should be fine. But I don't like to put stuff with chips in it back in. So for your inner race, you want to check this here, the surface. It needs to be mirrory smooth, no signs of scoring or anything like that, no heat, no signs of overheating. Here's your bearing. So this will get a whole new bearing kit. I'm not going to reuse any of those bearings. Check this flange, make sure it's not bent. Every once in a while one will come in all bent. You might be able to straighten it out, but a lot of times it's difficult. Alright, and then your one-way assemblies, you always replace those. So it looks like we got some rust here on the wavy plate. See if that'll buff out. Yeah, it might be okay. Yeah, might be okay. All right, pump. So first thing you want to do with a pump is check the inner diameter of the stator. Reman stators, or new stators I should say, they're not reman, they're new, are available from Transtar, and I think they run like 55 or 60 bucks. You can buy them for any vintage, a 700R4, 4L60E. And it's recommended that you do so if you have either a ring cut in here or if you have spline wear. Spline wear is very common in these, and you obviously don't want it going back in and have some sort of failure inside the torque converter with the splines because you didn't see that the splines were worn. Alright, this entire pump assembly is going to be replaced. I'll come back in with it. I have another one on the bench. It's already been machined and ready to go. Alright, some cobwebs and other whatnot in here, organic material. So otherwise it just looks dirty to me, but when it comes to reusing the rotor and the slide, you're going to really check for only a couple of things. You want to check in here at the engagement lugs, make sure there's no fracturing, nothing that would lead you to believe that this thing is no good. And then obviously check the rest of it, but I mean if it's fractured somewhere else it'll be obvious, but I seen hairline fractures in here before, so when that's cleaned up, I'll do a more thorough inspection. Let's get this out of here. So got a dual spring setup, and I think they went to a single spring setup for the priming spring or slide spring in either 04, 05, somewhere in that time frame. So we have our slide, and then this is going to be our slide support, and then there's a support O-ring underneath. So entire pump kits are available in the aftermarket, or you can buy them from GM. I recommend OEM whenever possible with the rotor and slide, but I have used aftermarket sets, and I've so far, knock on wood, I haven't had any come back due to premature failure. And here we're talking all the way back about, I'd say at least 7 years. So here's your little pivot pin spring. Incidentally, you can use this in 700 R4s to block off your 3-2 control valve or 3-2 downshift valve, if you so desired. So you put the spring in, then the valve. You can also use a 1/4-inch cup plug. So for your rings, if you're doing anything high performance, it's a good idea to run the Transgo Unbreakable Pump Ring Kit. They come with the rings and a updated slide spring that's more akin to what GM provides in their 05 and up or 06 and up or whenever they changed it, 4L60s. So as far as checking the slide, the area in here is what you want to scrutinize. You want to see if there's scoring or wear. You see the coating. The coating's got a little bit of wear to it. I mean, you can kind of see something here going right down the middle, all the way around the circumference, but this is not alarming. If you saw scoring or this was all worn off, then you'd just dump the slide. You wouldn't reuse it. Alright, you can check the working surfaces if you want. I usually don't bother because I always machine, or I always put a machine surface, especially the bodies. The stator sometimes, or the stator support I should say, sometimes is actually okay. You know, you can sometimes have a stator come in that will not be worn, that'll actually be perfectly flat, where the body is just, you know, not and needs machining. So that can happen too. Alright, you're going to vacuum test these two valve trains in here. So this is going to be the inboard location where you're going to test, and then you're going to test this little orifice. And when you test the orifice, you put a finger here and you push inboard. Okay, for your pressure regulator valve balance spool, there's going to be a little hole. I think you might be able to see it right there in the valve. That needs to be plugged with a pencil eraser. Then what you do is you put your tester over here, and you see what you have. Anything between 11 and 14 inches for the pressure regulator valve is okay, provided you install the Transgo drop-in oversized pressure regulator valve. That should restore it to like between 15 and 17 inches of vacuum. If you're in the single digits or maybe even 10, then just bank on reaming this out with an oversized valve reamer that Sonics makes and installing their oversized PR valve. Okay, I do that from time to time. I'll do it on all high performance 700Rs, 204Rs, and 4L60Us, just, you know, because. But for a factory to mild build, it isn't necessary unless it's necessary. In other words, unless you have significant vacuum, you know, shortage or sealing integrity issues there. Okay, I'll clean that pump off. But it's basically a core, and so is the stator support. Alright, I think that pretty much does it. Let me go bring this 1-2 accumulator housing, get this piston out of here. These plastic pistons, they're not as prone to breakage or failure as, I guess, as some would like you to believe, but if you are going to replace it, do replace it with an aluminum one. It's that much better, you know. For, I think they're like $3. It just doesn't make sense to reuse these. A lot of times you'll have wear in the pin bore, especially for the 3/4 piston and 3/4 accumulator location. So Transgo shift kits come with different springs in here. I'll be honest, I wouldn't use them. I see too many of those come in where those springs are broken. So I typically will either reinstall the factory springs and just simply offset that you know, the spring tension difference by sizing the orifice or putting a different spring in the accumulator regulator valve in the valve body. But it's too common for me to use their springs. You know, too common to see them broken. So Sonex also makes springs if you want to use those. They have a regular factory level spring, and then they also have a super heavy duty spring that will stiffen up that 1-2 shift considerably if it's too soft. In these transmissions, that's usually not a problem. It's usually the opposite issue. Too firm a shift. All right, let me back this up a little bit and we'll kind of recap. So in summation, we have a total mess in this transmission. You know, about half the hard parts, if not more so, are going to have to be replaced. Everything from the pump, the bell housing, the valve body spacer plate, the 2 drums, the gear set in the rear, you know, ring gear planet, and you know, a bunch of other things that normally you wouldn't have to replace. Now, the case itself, that what remains of that bell housing, the case bolt, that little, you know, stud, I guess, if you will, that's, you know, what it is now. If I can't get that out, then I'm just going to go buy another core. And you can argue that I should do that anyway, given how many parts in here are no good, how much has to be replaced. So the pan, that's, you know, it's got the wrong friggin' pan on there. You know, we need to put a deep pan. So the only reason I'm not probably going to do that, assuming I can get that stupid stud out of the case, is I have so many parts, you know, in inventory, and frankly, I want to get rid of some of it because it's taking up a lot of space. So I can just use those parts in this build. And I mean, normally I don't like to give away parts for free, but you know, when you're doing a core build, you have to make sure you build in some contingency in your pricing. You know, if you're not going through the customer's own transmission, and that's really the main takeaway here. Not so much what you saw. I mean, you know, that stuff's interesting and all, don't get me wrong, but the main takeaway, especially for those that are either looking to purchase a core to rebuild as a do-it-yourselfer, or are thinking of getting into the business, especially if they're thinking of starting their own transmission building business, you need to de-risk your, you know, your pricing when it comes to cores. And the way to do that is to build in contingency for commonly replaced hard parts. So I always build in you know, a buffer, if you will, so that I can replace both the drums as well as the gear sets and still make what I want to make in terms of margin, in terms of overall raw net to me. And if, you know, the customer wants to haggle with you, or, you know, your price is too high, then my advice to you would be not to take the jobs at all, as opposed to coming down and, you know, eating so deep into your potential profit that it just simply isn't worth your time. You know, I mean, they say time's money, but in reality, time is priceless. So, you know, you're really putting yourself in a bad spot if you don't build in that contingency buffer. And so, you know, that's kind of the main point, overarching point that I want to, you know, drive home with this particular video. So core builds always carry a little bit more risk, so you got to price them accordingly. Risk-based pricing is going to be your best defense against, you know, too many bad deals pushing you out of the business. All right, guys, as always, thank you so much for watching. Greatly appreciate it. If you have any questions, comments, go ahead and leave below. If there's anything else that you you know, want to see, or if there's anything you'd like me to do differently with these videos, please put something to that effect. As long as it's done tactfully, I'll go ahead and take it under advisement and implement changes, you know, as needed. So anyway, thanks so much for watching, and enjoy the rest of your day or evening. Look forward to seeing you on the next one.